Hey, welcome back. In this video, we're dealing with finding exact value of expressions. So we moved on from a single trig ratio to multiple trig ratios in operational settings. So there's some sort of operation going on, multiple operations. Like if I look at the first one, that one's asking me find tangent of 45, then also find cosine of 30, and then being able to multiply them. If there's no operation, it's defaulted to multiplication. And I'll show you some addition subtraction one as we go along. The first one is tangent of 45. 45 is in the first quadrant. So we're looking at 45. That's a 45, 45, 90 kind of special triangle, which makes the legs equal 1 and hypotenuse equal to root 2. Now tangent would be opposite over adjacent, so that's value is 1. Cosine of 30 degree. 30 degree again is in the first quadrant, so we have a 30, 60, 90 triangle going on here. Opposite to 30 would be the smallest side, hypotenuse would be 2, and the leftover side would be root 3. Also, cosine is adjacent over hypotenuse, which means root 3 over 2. So that value is root 3 over 2, and I go ahead and multiply them. Anything multiplied by 1 is going to be the same thing. This answer works out just fine because there are no radicals in the denominator, and it's completely simplified. So that one's done. Looking at the second one, cosecant of 45. Now I just drew the 45 angle here. I'm going to use this one. Cosecant of 45. Cosecant would be, cosecant is the reciprocal of sine, which means cosecant is, I don't want to write c actually, it's cosecant, it is reciprocal of sine, which makes it hypotenuse over opposite. Here's my hypotenuse, and here's the opposite side. One more time, hypotenuse and opposite, so root 2 over 1, which is just simply root 2, times tangent of 60 degrees. And let's draw a 60-degree angle. 60 would again be in the first quadrant. And that's 60, 30, 90. Opposite to 30 would be the smallest side. Hypotenuse is twice of that. Leftover is root 3. Tangent is opposite. TOA, tangent is opposite over adjacent. So 60 is our reference angle. The opposite to that is root 3 over adjacent, which is right here, because this is the hypotenuse, so root 3 over 1. Now that simply multiplies to top, which is root 6. 1 times 1 is just 1, so simplifies to root 6. Let's try some more. Let's say we have a 5 times, I'm going to stick to degrees for first few problems, then switch to radians. Cosine 90 minus 8 times sine of 270 degrees. Now if you notice here, this one's asking me 5 times the value of this. If I were to highlight this, that's also a bad color, sorry. The 5 times cosine of 90 minus 8 times sine of 270. So 5 just comes over. I'm going to fill in the value of cosine 90 here and fill in the value of sine 270 there. If you notice, both 90 and 270 are quadrantal angles, which is what I discussed in the previous video. So there are no triangles that's gonna work because we are on the quadrant itself. 0, 90, 180, 270. The point that corresponds to this is 0, 1, 90 is 0, 1. This one's negative 1, 0, and 0, negative 1. So we are only focusing on 90 and 270. So to find cosine value, cosine is adjacent over hypotenuse, but like I said, there's no triangle associated here, so I can't use that. Earlier in the previous video, we had mentioned that any given point, x, y, x will always correspond to the cosine value of that theta, and y will correspond to the sine value of that theta. Now let's see, cosine at 90 degrees is simply the x value. So cosine of 90 is actually 0. And then 8 times sine of 270, which is this location, sine is the y coordinate, or negative 1. But this boils down to 5 times 0, which is 0, minus 8 times negative 1, that makes it plus 8, which equals 8. Final answer, 8. Also remember, this turned out to be a quadrantal question. Here's a non-quadrantal one, also in radians. pi over 6. So we're looking at 2 times the value of sine of that minus 3 times the value of tangent of pi over 6. Let's quickly do our conversion. Pi over 3 in degrees is a 60-degree angle, and pi over 6 would be a 30-degree angle. So we can use our special right triangles. Okay, so this one's asking me find sine of pi over 3. Like, okay. Which is basically asking sine of 60 degrees. 60 degrees in the first quadrant. So I construct a 60, 30, 90-degree angle. Label them. The smallest side would be the one opposite to 30. On this side 2, and this would be root 3. Sine is opposite over hypotenuse. This is the reference angle, remember? Because pi over 6 is the reference angle, which is 60. So that's our opposite, and that's our hypotenuse, root 3 over 2. Tangent of pi over 6, again, pi over 6 is in the first quadrant, and pi over 6 is 30 degrees, so we're creating pretty much the same angle, except 30 is at the bottom. Left side would be 1, 2, and root 3. And then this is the opposite, that's the hypotenuse, and that's the adjacent. Tangent deals with TOA, so that deals with opposite over adjacent, which is 1 over root 3. Now I need to start solving it. Computation part begins. 2 over 2 would cancel that. We have root 3 minus 3 over root 3. Can't subtract them because we have different denominators. Hence, I'm going to multiply this by root 3 and root 3 so that we have common denominator. Root 3 times root 3 is simply 3, and then we have 3 here. That actually boils down to just a 0. So all the above, the answer to all this above is simply 0. Yeah, we had to do some work. Construct 2 triangles. Let's do one more and I'll wrap up the video then. 5 examples. I'm trying to pick and choose. Well, here's a good one. Secant of pi minus cosecant of pi over 2. What does that equal? If you notice, here's a quadrantal angle. This is also a quadrantal angle, so we're back to quadrantals. Pi is this angle, and pi over 2 is that angle, so let's mark the coordinates there. And this would be -1, 0. Also, this will be the cosine value, sine value, cosine value, and this will be the sine value. Secant of pi. So cosine is -1, hence secant would be reciprocal of -1, which again turns out to be -1. So that's -1. Cosecant pi over 2. Now cosecant is the reciprocal of sine. So we can find the sine value there, which is 1, and reciprocal that to find cosecant. Reciprocal 1 is also 1. This turns out to be -1 minus 1, which boils down to -2. So what we're saying is that secant pi minus cosecant of pi over 2 is simply -2. And those were my examples. See you in the next video with the other topic.